Okay, section 1.2, our objectives are we want to make and interpret dot plots and stem plots of quantitative data. We want to be able to describe the overall pattern of a distribution and identify outliers. And we want to be able to make and interpret histograms of quantitative data. So first, let's talk about a distribution. The distribution of a variable tells us what values the variable takes and how often it takes these values. So if we have a data set of heights, it's going to be all the numbers graphed or all the numbers arranged in a different fashion. There's lots of ways to arrange your data of the heights of people. Okay, when you have a distribution and they ask you to describe a distribution, you are required to comment on the center of the graph or the distribution, the shape of the distribution, and the spread of the distribution every single time. It must include all three. You also need to talk about potential outliers. We know that an outlier is an observation that appears to be inconsistent. It can be an extremely high value or an extremely low value, depending on what we have. All right. There are four main types of graphs that we have. The first is when we talk about something being skewed. If it's a left skew graph, that means it's pulled down to the left. It's thinner on the left. If it's a right skew graph, that means it's being pulled thinner to the right. Okay, so here is a histogram, it's being pulled to the right. Here's a left skew histogram, it's being pulled to the left. Okay, skewness, I think of like ski-ness. If you're going skiing, right, a left ski would go skiing down the left-hand side of the mountain. A right ski would ski down the right-hand side of the mountain. So it's a right skew, a right ski. Then we have a normal curve, which can also be called a bell curve. A normal curve or a bell curve is where it literally looks like a bell. It doesn't have to be perfect, but it's that general shape. So here's a general shape here of a normal. It's a general shape here of symmetric. Now, yes, a normal or a bell is symmetric, but a better term is to call it normal or bell. Okay, here is an example of symmetric. Don't call this a reverse bell or an inside-out bell. That doesn't exist. It's just, this would just be considered symmetric. So anything that's plain old-fashioned symmetric would go here. Now, we have a bunch of different types of graphs. So first we have dot plots. Okay, if we talk about a dot plot, here, if I give you this example of the number of Snapchats that 31 teens sent, okay? If you look, all right, I already circled that these are possible outliers. Hopefully you agree with that. They're high. I'll talk later about how we can test for outliers tomorrow or in a couple videos. But here we've got, these are possible outliers, but we've got our general shape of our histogram here. Of our dot plot. So what I want you guys to do is figure out what the center is, what the shape is, and what the spread is of this data set. Okay. The center is 6. The shape is right skew. And then the spread, I would use the term range to describe that. Take your max values, subtract your min. So do max minus min equals, and it got 25. Okay. The next type of graph we can have is a stem plot. I'm sorry that my phone is ringing across the house. So a stem plot is, and you guys have seen these graphs a million times. So a stem plot, you've got, let's say I gave you a data set of ages. All right, and you've got all those ages there. Okay, you've got all those ages here, 7, 12, 12, 16, 20. I set up my stem plot. When you were in middle school or elementary school, it was called a lot of times a stem and leaf plot, where here's a stem and then here's the leaf. So the number 7 is really 0, 7. So you have 07. There are two 12s, so you're going to put 12, 12. 16 is 1, 6. The number 20 is 2, 0. 24, 26. We have 30. There are no 40s in this data set, but I need to include the number 4 because you need to have them all there. And then for 55, I put 55. All right. A stem plot you can't make on the calculator, but it is a nice way to organize your data. All right. If you tilt your head to the right, you can see the shape. If you tilt your head to the right, this is a right skew because you have these like skiing to the right over here. 55 is a potential outlier. All right. To find the center of a data set this small, you could literally just figure out what's the middle. You can go 1, 2, 3, 4, right? 5, 6, 7, 8, 9. There's 9 values, so the center value of 9 would be 20. So 20 would be the center point. Just like back here, I found this 6 by saying, okay, there's 31 teens. So that means that teen 16 would be right here. I just literally count 1, 2, 3, 4, 5, 6, right? Because teen 16, you'd have 15 higher, 15 lower. So teen number 16 is right in this space. Okay, what's neat that you probably haven't seen before is something like this, a back-to-back stem plot. So a back-to-back stem plot is when you could read it both ways. So these numbers, notice my stems turned into 2, okay? This is smokers and non-smokers. All right, and maybe we talk about cholesterol levels or something. So I would read this as 100 and 108. I'd read this as 111, 115. This number here would be 174, 176. So on the other side, smokers, you read still from the inside out. So this would be 111, 120, 123, 130, 132, 134, and so forth. Smokers absolutely looks like a normal or a bell shape, okay? Non-smokers, I'd say is probably, this one is a little wishy-washy. This would be hard to determine, okay? You can't say it's normal and right skew, but you could say this is approximately normal, or you might be able to say this is slightly right skew, although I'd say approximately normal is a better description for it. Now, if I asked you overall, compare these two distributions, non-smokers have a much lower cholesterol overall than smokers. You know, smokers goes up to 190s and 200s. The highest non-smoker is 1. All right. So you can absolutely see problems that bring into play all of these different types of things.